In this video, I want to take a couple minutes and talk to you about your projects, what I'm looking for, kind of the purpose, and give you some hints and maybe set some expectations as to what I'm looking for throughout the semester. This is obviously project one, but the other projects will have a similar discussion attached to them to let you know what we're looking for. So the main thing I believe is that I can teach y'all until I'm blue in the face. I can be up in the front of an auditorium, or I can be online in some video format, or whatever the situation is with your particular class. I can teach you, and you can copy the notes, and you can diligently write down the information and listen and nod your heads. But I think a lot of learning takes place, at least in this class, experientially. And what I mean by that is actually working with data, doing the work and trying to apply things I've taught you in class to the data that you've collected yourself. And so that's the purpose of the projects, to try to get you hands-on experience answering simple questions. Now, we have a very small data set this semester. You're not going to light the world on fire. You're not going to be able to predict the price of a car to within $10 at the end of the semester. But you will be able to go through the process of all the things we talk about in class, and you'll be able to take things I do in lecture time and apply it to your data, or do similar problems to other data sets, depending as the case may be, depending which project we're looking at. So with that, what I want you to do first is just tell me about your data. Tell me what the experimental unit is. Very early in the semester, probably first day of class, we've talked about the experimental unit. It's the object we measure. It's a single thing. If I was collecting data with students and working with student GPAs, an individual student would be my experimental unit. The GPA would be a variable. It would be a quantitative variable. And so those are the pieces. I usually refer to them as the basic elements, or some of the basic definitions of where we start a semester. I want you to tell me about your data. Tell me what the experimental unit is. Tell me which 3 model years, because I'm asking you to do 3. So is it 2012 through 2014? Is it 2020 through 22? Tell me which 3 model years you used, and then explain your variables. There should be 3 of them. And you tell me whether they're categorical or quantitative. You should have 2 of one and 1 of the other. I'll give you a hint there. And then for your categorical variable, tell me what specifically, when you enter the data as 1s and 2s, which is okay to do, what do they represent? Are they Honda Accords? Are they Nissan Altimas? Are they Ford F-150s? Be specific. And you should have 2 different models that you're working with. It shouldn't be a Honda Accord and then another type of Honda Accord. It should be a Honda Accord and then a comparable car, like a Toyota Camry. So page 1 is very straightforward, very simple. Just tell me the variables that you're working with. All right, let's see, where's my cursor at? In another video, I showed you how to generate the printouts that you need for this project. There's only a couple of them. You got a histogram, some descriptive statistics, some box plots, but I've showed you how to do that. So you're looking at a histogram right now. Wherever you got that, you're using Excel. Follow my demonstration video to see how to do that step by step. But I want you to paste that here. And you may need to resize. You may need to use a snipping tool, or whatever the Apple product is that you use to snip or to copy and paste. Take a picture with your phone, but I need to see your histogram of your prices, and I want you to tell me the shape. And the shapes that we've looked at so far, and this will change through the course of the semester, but we have symmetric and we have skewed. And then we have some like crazy shapes too that we can talk about. And really where I'm heading on the next page is we're talking about 3 different rules, 2 different ways of describing data. We have Chebyshev, we have the empirical rule, and I'm giving you another one called the modified empirical rule. And you need to use this shape to kind of consider which of those 3 rules applies, and that's going to help you with some answers on the next page. So take a look at your shape here and just write a sentence. And most of the answers you're going to be writing for me this semester, please hear this very clearly, are 1-sentence answers. Almost every single project is either do a work and come up with the answer, or give me a 1-sentence answer to the questions that I'm asking. When you're doing more than that, you're not approaching it right. A lot of times people, rather than take a look at what I'm doing in the class, are going to try to Google the responses and search, and they come up with all sorts of weird stuff, extra stuff, sometimes right, sometimes not right stuff. Keep it simple. Take a look at what we're doing in class and just make it work. So if I was looking at GPAs, I might say, based on the histogram below, I believe my student GPAs are approximately symmetric. Or maybe they're skewed to the right or skewed to the left. But just give me what your assessment is of the shape here in question 5. 1 sentence. Use words. Don't just say the data is skewed to the right. The prices, because you're working with prices of vehicles. You're also going to be creating some descriptive statistics. You're going to be creating the mean, the median, the number of observations, that's n, standard deviation, minimum, maximum, and the count. I show you how to do that, and the count of the variables specified is also the n. I don't know why I listed that twice. Give me the printout there, and then tell me what the mean is. Now, last semester, or maybe a couple semesters ago, I asked for the median. Now, in the notes, I'm going to tell you the median is the halfway point. If you order the data from small to large, the median is a halfway point. I don't want you to tell me the median is a halfway point. Or I don't want you to go to your printout and find that the median price is, say, $20,000 and say, just put the value 20,000. That's what the printout tells me. I want you to expand on it. I want you to take these interpretations. So again, if I was asking you for the median and the median was 20,000, I would say half of my 70 vehicles have prices that are less than $20,000. Half have prices that are more. One sentence. That's what a median is. Now, I'm not asking you for that this semester. Tell me the mean. The mean is an average. That word should be in there. Prices should be in there. But just give me a sentence. Tell me the mean. It's not rocket science. It's very straightforward. Same thing with the third quartile. Third quartile is a very specific value. It tells us what percentage of the data falls below a particular point, what percentage falls above. Don't just give me the number. Express that and tell me, give that number, but express what it means. Tell me the percentage that fall below that amount, the percentage that fall above. What I talked about just a little while ago, which of the 3 rules covered in class would you use to describe where most of your prices fall? Well, that's going back to the shape. Based upon the shape you told me about on the last page, what do you think? Which of those rules would you use? And then use that rule to interpret the standard deviation. Again, one sentence. Where do we expect most? I've talked about how most is like 95% of your data. Apply the rule to your data. And in the printout here, you have a value of the mean, you have a value of the standard deviation. You got to do a little math. I expect most of my prices to fall between here and here. And then do the math. Tell me what it is. Take the numbers from the printout. You have the maximum, you have the mean, you have the standard deviation. Do the math here and calculate the value of the z-score for the maximum. Is it an outlier or not? Yes or no? Tell me which one and why or why not. And the way that you answer that question is going to be very much tied to the rule you tell me about here in the question above. If you're using Chebyshev, you're going to use one way of determining whether it's an outlier or not. One rule, I guess I could use. If you're using the empirical or the modified empirical, then you would use a different rule to tell me whether it's an outlier or not. So just go through that process. And last page, I'm not real wild about. Excel's box plots, they just put dots in there. They make it really simple. Most software packages give you a couple different options for the dots, a couple different plotting symbols, but Excel dumbs it down and just gives you a single plotting point that's a dot. And basically, you're going to be creating 2 box plots and tell me how many price variable dots you have, how many outliers you have, and how many mileage variables. You don't have to do anything more than say for the price variable, I have 2 outliers. For the mileage variable, I have no outliers. And if you have no, express that. And then just copy and paste your box plots. And that's it. Pretty straightforward stuff here, folks. Very simple, very easy to do. Now, the tendency on projects, the tendency for students, the tendency for people, quite honestly, is to wait until the last minute to do things. And we always think if I do it here, I should have enough time. And when we think like that, it's due on February 1st. So if I wait until January 30th to start this, I should have plenty of time. And you should if everything goes well. But if you have trouble with Excel, if you have trouble with finding data, if you have trouble with anything that's going to throw a kink in your plan. So what I always suggest, start early. Okay, first week of class, collect your data. Put it into a spreadsheet, upload that. If you're using the application gateway at USF, make sure you know that process. Get your process down first, create your printouts in the first week of class, and then you can answer your questions. But I also recommend you work early because if you have questions, we're available. Myself and the teaching assistants have office hours, but they're only Monday through Friday. So if you wait till the weekend before it's due to start, you're on your own. You're an island. And while you might pull that off and do great things with it, you might not. And you don't know right now. So work early and get your question answered when you get them. And I promise you the projects are going to add not only to your knowledge, but also to your score at the end of the semester. So get to work. When you have questions, reach out to us. You know how to get hold of our office hours. And good luck.